Okay, so here's a really interesting problem, which introduces like a nice introduction to p-adic number theory. It's awesome. So we have problem 3, find the smallest value of n, so as the n choose 4 is divisible by 16. So if you recall, yes, p choose a, the formula for that is p factorial, brackets there, p factorial, a factorial, p minus a factorial. And this is basically the number of ways to arrange a objects within, well, a items within p total objects. Pretty cool. But then I want to see it's divisible by 16. So we see that n choose 4, n choose 4. So n factorial, 4 factorial, or n minus 4 factorial. And if we recall that n is bigger than 4, therefore we can write n factorial as n minus 1, n minus 2, n minus 3, times by n minus 4 factorial. So we can cancel this down. 4 factorial or n minus 4 factorial. Boom, boom. So now we have n minus 1, n minus 2, n minus 3. It's all over 4 factorial. Now, if we notice about what is special about these numbers, they're consecutive, right? So we know that if you have 4 consecutive numbers, so 4 consecutive num, we're going to have a multiple of 2, a multiple of 4, and a multiple of 3. So that's really handy. So we know that this is going to help for some divisibility. So let's see what happens when we divide it by 16. So divided by 16, we 2 to the 4. And then we're writing this as prime factors. n minus 1, n minus 2, n minus 3. All over, we have 4 times 2 times 2 times 1. So that's 4, 3, 2, 1. Or it's 1 not really needed there. So we know that we have 2 to the 7. 7 multiplied by 3. So our goal now is just to find out the smallest value of n such that this thing goes to an integer. So this thing belongs to an integer for what value of n? What is the smallest value of n? So think about it, you kind of might see that the term 3 here is a little bit ugly. But we know that because we have 4 consecutive integers, we don't know which one, but one of these integers is going to be a multiple of 3. So we don't have to care about the 3. The 3 is basically not even there, which is awesome. But now we have to think about it. We want to have 2 to the 7 in our numerator, and how do we get that? If you look at the spacing of the numbers, so we know that we have 2, 4. So these are the things that are going to contribute to adding up to this value of 7. So we know that we're going to have a multiple of 2 and a multiple of 4 guaranteed. So we're going to have minimum a multiple of 2 to the 3. So if we try maybe like, I don't know, n is equal to 5, let's say. And with 5, we have 5, 4, 3, 2. 5, 4, 3, 2. 2 to 7, 3. We don't really have to care about the 3. But this only contributes 2 to the 3, and we need 2 to the 7. So we need to go up more a little bit. And we find out that we only contribute because the 4 term, it doesn't really contribute much. It contributes 2 to the 2, or 2 2's. So let's see what happens. Maybe if we have 2 to the 5 as n, let's see what happens when that is the case. So 2 to the 5, 32, 31, 30, 29 over 2 to the 7. We can just ignore the 3 term for now because it does not matter. This is equal to 2 to the 5 multiplied by 2. Ooh, okay. See what happens here is when our multiple of 4, when we have a multiple of 4 that is a a power, which is a power of 2. So it's gonna be like it's a perfect multiple of 4 basically. So it's gonna be like in the form 2 to the k multiplied by 2 to the j. And that creates a multiple of 4, but also creates a multiple of 2. You can add on to it. So you need that this did work. And I guess it's kind of a nice little balance. We can keep on going until we find out a nice value. Let's see what happens 2 to the 6. If you can really see that this term, okay, is only going to contribute. Sorry, one thing I overlooked. Pardon me. I would edit out, but I'm here now. The multiple of 2 to the power of n. This is always going to be a multiple of 4. Yeah, this is always going to be a multiple of 4 for n bigger than 1. So n for n equal to 2. And 2 is congruent to 0 mod 4. Which means it has a remainder of 0 when you divide by 4, because if we have, let's say we have like 2 to the whatever, like 39, we have 2 times 2 multiplied by 2 to 37. That's 4 there. So yeah, so pardon me about that. So our multiple of 2, so our 2 to the n in our expression here, we're only going to add in one more, 2, because we only have one more even number, and that even number is just a multiple of 2. There's nothing special about it. So therefore, we can say that okay, we need 2 to the 7. If we have 2 to the 6 as n, and then we have a multiple of 2 somewhere in our chain of consecutive integers, this works. If we want to check it, we have 2 to the 6 multiplied by 63, 2, 31, and we want to do 61, 2, 7, 3. Here we have a multiple of 3 in there. We have 6, 7. So yeah, so our final answer n equal to 7.